We're ready. Okay, so this is a review of yesterday's stuff. This is in vertex form, right? We get the vertex for free because of the parentheses squared. That's how you know it's vertex form. So we get the vertex for free. Like I said, what is the vertex? You guys remember? Be really careful. Nice, good job. -1, 3. But Mr. Cordero, it says +1. Yes, but remember in the parentheses act weird. So you flip the one in the parentheses and the one outside stays. This would be -1, +3. Meaning that I'm gonna open from -1, +3 right there. Nice. Okay, now I just need to know where to open to. So I just need one more point. I could use the width if I wanted to. In this case, I guess it's the same thing. But usually it's more accurate to do the y-intercept. So we do the y-intercept. How did we do that again, Trish?
Do you have the answer or how?
Oh, both.
Okay, well, you plug in 0 into the equation and you get 4.
Nice. F of 0 is 0 + 1 squared + 3. Yeah, good work. Then parentheses first, then exponents, then multiplication, then addition. You do all that, you get 1 + 3, which is 4. Very good, Chris. So here's 4. So half of it opens something like this. The other half would do the same thing on the other side of the vertex because it's symmetrical. Okay. So if you missed a week, like a couple of us have missed a couple of days. That's what we've been doing. It seemed fast, but if you do enough of them, that'll make sense. Now, here's the stuff we've seen. Standard form, which gave us the y-intercept for free, remember? Vertex form, which gave us the vertex for free. And now we have a new one called factor form, and this is the last one. So we did this, now we're doing this one. And this one gives us two different things for free called the roots or the x-intercepts. And this one, I think it's not super, and this might be the easiest one. I'm not sure. We'll see what you guys think. But before we get into that, I just said some words that you might not know what it means. This R1 and R2 stands for the first root and the second root. The following words, therefore, root or 0. Ooh, this wrote zoo. Root or 0 or x-intercept all mean the same thing. It just all means where you're going to cross the x-axis. So all these words refer to the x-coordinate at which the graph crosses the x-axis. So these 2 points, 2 and 5 here. All right. Now, as you can see, there is a connection between these factors and where we cross the x-axis here. And actually, I guess I gave it away. I already typed it. But the factored form of a quadratic function immediately gives us the roots, the zeros, where we cross the x-axis. And it's fun to think about why. It's not the super hard. So think about why it might be that x - 2, x - 5, that function crosses at 2 and 5. Think about what value the function is at these points. Think about it, think about it, think about it, think about it. Okay, why do I cross at 2 and 5? You guys have any ideas? Okay. There's not that much deep math into it, but it's because, okay, this function would have a y value of 0 right at the y-axis. Yeah. So in this case where it says y equals whatever, my y value, if I'm interested where I'm going to cross the axis, is going to be 0. The y value will be. So I'm looking at where is this function going to take a value of 0. Oh, okay, all right. And then this should look familiar like last unit. Number times number equals 0. So the two places where this is going to happen is where this red number is 0 or where this green number is 0, which we've seen is at 2 and 5. Wait, what? I don't remember that. Remember you set each number equal to 0? Either x - 2 equals 0 or x - 5 equals 0. Those are the two scenarios where this whole function will have a value of 0. Okay. And so therefore we cross at x equals 2 or at x equals 5. Did I just speak a foreign language to you guys, or do you guys kind of remember this? Okay, all right, good. Cool. So that's why there's not that much deep math behind it, but I mean, it makes sense. Hopefully you understood that. Okay, so now it's just about graphing these. And like I said, I think you might like this one the best, but we'll see what you think. Okay. So to graph these, well, you take the points that are given to you. Like in this case, you're given the roots for free, so write those down. So first step is identify and plot the roots. These are the numbers in the parentheses. Remember to twist the signs. Okay, so in this case, my root would be -1 and 3. -1 and 3. Okay, now don't read anything else, but here are 2 points on my parabola. Where, therefore, is the vertex? Yeah.
Well, because it's symmetrical on both sides on the other thing.
Exactly. And you know the parabola is symmetrical. So if you have 2 numbers on the same horizontal line, the vertex has to be directly between them, like exactly between the 2. So the x-coordinate of the vertex will be directly between your 2 roots. We talked about y. Find the number directly between the 2 roots by dividing their distance by 2. Yeah, sure. Or you can just do the following. These 2 are how far apart? Let's check. 1, 2, 3, 4 apart. So the vertex will be how far apart from each of them? Yeah, exactly. Halfway between them. Okay, so the vertex will be 1, 2 apart. But the thing is, will it be here? Will it be here, 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 here? Where will it be? So we only know the x-coordinate of the vertex will be 1, 2 apart. That's at 1, it looks like. See what I'm saying? So don't write 2 there. It's just 2 units from each vertex. We ended up at 1. Okay, and then to find the y-coordinate, you guys know how to do this. I have an x-coordinate. I have a function. How do I get the y-coordinate? Yeah, plug in. Good job. Plug in the x-coordinate of it. So to find the y-coordinate of the vertex, plug in x-coordinate. Okay, do we have room on this?
Maybe.
Kind of. Yeah, okay, let's do it. So this would be, here's my function. 2 times x was 1. So 1 plus 1. X was 1 again, minus 3. And now you just have a multiplication problem. 2 times 1 plus 1 is 2. 1 minus 3 is -2. That's what? Nice. Cool. So your vertex is at 1, -8. Maybe I write that. Vertex 1, -8. Here's your vertex. Oh, okay. And then you get a pretty accurate graph. Look at this. That's not bad. All right, cool. And then there's not really very many weird cases. There's like one that I remember putting on this worksheet, but the rest of them are basically exactly this. But if that didn't make sense, let's do a couple more together, and then I think you'll catch on. Okay, here I was running out of room, so I didn't have a lot of room to put like what's the roots, what's the x-coordinate, what's the y-coordinate. I just wanted to get a lot of these on the page, so we'll do it ourselves. First thing to do is plot the 3 points that you're given. So what those would be my roots, like my zeros, my x intercepts. So in this case, what would those be? Be really careful. Good job. Yeah, remember, flip the signs. So even though it says +4, that's a -4. Even though it says -2, that's a +2. All right, cool. So I have 2 points on my parabola. I know my vertex has to be exactly between them. So where would that be? Let's check. These are 1, 2, 3, 4, 5, 6 units apart. So my vertex would be how far apart from each of them? Okay, sweet. Okay, just making sure. Okay, so you count 3 over from either one of them. 1, 2, 3. Here is where my vertex will be. So maybe let me make a note of that before I forget. Vertex is at -1. -1 comma something. All right, now I just need to know where on this -1 it is. So I plug in -1 and I find out what number that is. Okay, what's this? 3, -1 plus 4 is 3. -1 minus 2. If you guys remember negatives, what is -1 minus 2? Okay, all right. And then you get -9 and you smile. So here's your vertex, -1, -9. -1, -9 is here. And that's them and you're done. Did I even ask for domain or range or anything? No, easy day, nice. Okay. How do you feel? You want me to do more? Okay, then try the rest of these. There's one weird case, but I think you can figure it out. Actually, there's 2 weird things, first of all. The weird case is number 8, because look, there's no parentheses, it's just an x, but you know what that means, x minus nothing. And then this one is just like the vertex is off the graph. And the very last question, I think didn't print out right. I think I printed these before I finalized this problem or something. But you guys don't have this, so you can just skip the bottom. Okay, try these, try them. It might not take you super long. I'll walk around and help. There could be people who are totally confused. That's normal. I'll help you guys. Yeah, okay. Yeah, okay. So same process as before, you're given where you're gonna cross. That's these 2 things. Fine, so. Okay, so just make sure where you. No, that would be the vertex, but you're gonna cross directly at them. So exactly at 1 and exactly at 7. No, see, yeah, that's the thing, you put the sign, it's the short. Nice. And then now we're going to talk about exactly between these 2. Like that. Yeah, so I like to keep track of that. I like to write that down. So you're going to cross your vertex will be 4. Now you just need to know where it's 4. Up here, down here. So find that out. 4 and plug it out so the x is. And you find out what number that is. 4 minus 1. Yeah. Nice, and then there was a -1. Good. And well, perfect. Yeah, okay. All right, so now you find out what number that is. 4 minus 1 times 4 minus 7. Yeah, and then because of the negative in front, so they would be negative. So then 4, 9. Nice, and then there's a crowd. Yeah, no worries. Yeah.
How did you like get all that? Because there's no. Oh.
I did exactly this. So I said, so I know for sure this the vertex will be directly between the 2. So that would be where you have it at -1. Well, okay, that could be in a bunch of places. Is it gonna be here? Here, it's gonna be here. No, that's actually good. Oh, wait, no. Okay. We have 0.37. Oh, yeah. Why?
Because you said here.
Yeah.
go over 2, and that's the number you plug in for this. You solve for this. So I was moved over 1/2. And just went back.
Oh, I just meant, so in this case, it happened to be 2 because these 2 points are 4 apart. But the vertex is always gonna be exactly between the 2 points. You know what I mean? So in your case, in that bottom. Sure, yeah. Okay. So in your case, since you're 2 apart, exactly how close.
Wait, so
I get it right. You got this negative.
Or is that it's gonna be 3 and then we'll have to have to jump. Oh, I don't get the right. -4. Wait, -4. Oh,
Because if you have to distribute, then it'd be the opposites.
oh, that's,
Did I not get that right?
that's reasonable, but no, you don't want it to stay, any number out here, leave it alone. Just go by the parentheses, do the same thing every time. Yeah, that's reasonable though. I didn't even think of people doing that.
Oh,
Here, and then a 3, and then fill in the. Okay. Yeah. Don't leave, okay, leave the fraction alone. Fill the number in parentheses or what you do first.
Would it just be negative?
No. Leave, pretend this isn't even here.
Oh.
Always gonna ask. But except flip it. Remember, -6 is what's at plus, like +2 is what's at like. Flip it. Nice. Cool, okay, and now the vertex will be directly between the 2, so find out where it will be. Okay. It'll be a -2, now find out what plug in -2 equality, and that's when the fraction will do something. Not until. Right, now we're looking at the whole function now, so this -4, what should be considered. There you go, then you find out what number this is, remember that, multiply by -4, first of all, you could do it on half, and then this is like dividing. You do it either one you want, then you get a number, and that's your. Right.
There's just, well, let me let it. You know, to like parentheses, I didn't mind.
Nice. No, you already combined the -4 with this.
Also, we need to.
Yeah. Why is it? Oh, because it should be negative. Okay, now you're done with this, now it's time for the -4.
You do.
Now it's gonna be positive there. Yeah, I got you. So then your change is
How'd you get that?
negative. That's, yes, exactly that.
No, it's not there.
Oh, shoot, the video's still going.
No.